After all the troubles that we have to learn the complex numbers, the complex domain, the phasor domain, and the triple identity, now it is time to collect the reward. The reward is that Kirchhoff law can be extended to frequency domain, which means phasor domain. We know the strategy of Kirchhoff law, meaning KCL and KVL. We can use the same strategy to analyze AC circuit where the sinusoid is involved. We use small rectangular to represent any elements in phasor domain. This element can be resistor, inductor, or capacitor. Although the voltage and the current are complex numbers, they still need to be defined. So the voltage needs to have the sign defined. The current needs to have the direction defined. In this case here, direction of the current and the sign of the voltage follow the passive sign convention. All of these elements we can see are in series connection. The equivalent impedance, so that's Z equivalent equals to Z1 plus Z2 up to Z of n. If two elements are in series connected, there is a voltage source here, and note that passive sign convention is followed here. We can use the voltage division. So V1 equals to Z1 divided by Z1 plus Z2 multiplied by V. Note that all of these calculations are carried out in phasor domain. Everything is complex. If the device follows this connection, we can see they are in parallel connected. The equivalent impedance follows this relationship. And this relationship has the same format of when the resistors are in parallel connected. When all the elements are in parallel connected, the equivalent admittance is the summation of admittance for each element. If this circuit is connected in parallel, only two elements are involved, Z1 and Z2, they're in parallel. We can apply the current division I1 equals to Z2 divided by Z1 plus Z2 multiplied by I. So this is the same format as when two resistors are in parallel in DC circuit. The delta to Y delta transformation is also applied to phasor domain. In this case, ZA, ZB, and ZC, they are in delta connected. So this is a delta connected. Z1, Z2, and Z3, they are in Y connected. They can be transferred to each other. And if we look at the formula, this is exactly the same format as the resistor case. The only difference here is the impedance. All the impedance are in complex domain. They are complex numbers.